Now I want to talk to you about the quotient rule. Again, the quotient rule is when you have division. So we're going to say h of x is n of x over d of x. And I'm just going to shorten that to h of x is n over d. And n stands for numerator. That's the top of the fraction. And d stands for denominator. That's the bottom of the fraction. And so here's how our quotient rule goes. H prime of x is denominator times derivative of the numerator minus numerator times derivative of the denominator. All of that is divided by the denominator squared. Now notice, you start with the denominator on the top, and you've got the denominator on the bottom. So you start with denominator, you end with denominator. So example 4, use the quotient rule to find the derivative of the function. So I'm going to say our numerator is 4x minus 1. Our denominator is 8x plus 3. My numerator prime, that's the derivative of that, is going to be a 4. And my denominator prime is going to be an 8. And remember, the rule is start with the denominator, derivative of the numerator, minus the numerator, derivative of the denominator, all over denominator to the second power. Okay, so these are primes. They don't mean first power. They mean derivative. So our f prime of x is going to be our denominator. And look, whenever you have more than one term, got to put those parentheses. So 8x plus 3 in parentheses. N prime, derivative of the denominator is 4. Now minus is very important. It's not a plus. It's a minus when you're doing the quotient rule. Numerator, 4x minus 1. Derivative of the denominator is 8. And then the denominator of the derivative is the original denominator, 8x plus 3, but it's squared. This is your half credit answer. Okay. Now simplifying this, I'm going to distribute my 4 through here and my 8 through here, and I'm going to be careful when it comes to this minus sign. So first I'm going to get 32x plus 12, and I'm going to distribute first, and then I'll come back and do the minus distributive. So that's 32x minus 8. Don't forget, this is all over the denominator squared. So it's 32x plus 12 minus 32x plus 8. Got to be careful. This minus distributes here and here. So the negative and the negative make this positive that you see here. All of that and all of that is over original denominator squared. And we're still doing the algebra for the other half credit. So 32x minus 32x adds to 0, so that's gone. 12 plus 8 is 20 over 8x plus 3 quantity squared. So this is our f prime of x. And that's our final answer for full credit. Example 5. Use the quotient rule to find the derivative of the function. Our numerator, x squared plus 1. Our numerator prime is 2x. Put your parentheses around your binomials. Our denominator is x minus 4. Our denominator prime is 1 because the derivative of x is 1. So remember our rule. Our dy dx is going to be denominator derivative of the numerator minus numerator derivative of the denominator over the denominator squared. And the more times you write that down, the more likely you are to be able to remember the formula and to understand what it's doing. So our dy dx is our denominator, x minus 4, times our derivative of our numerator, 2x, minus our numerator, x squared plus 1, times the derivative of the denominator, which is 1. All of this is our denominator squared. So remember, we always start with the denominator in the top and end by squaring the denominator in the bottom. So we're going to distribute back these monomial factors, and we're going to watch the sign right here. So I get 2x times x is 2x squared, minus 2x times 4, 8x. And since this is 1, that's just going to be x squared plus 1. But I've got that minus out front, so it's minus x squared minus 1. All of that is over our x minus 4 quantity squared. So combining like terms, 2x squared minus 1x squared is 1x squared minus 8x minus 1. All of that is over x minus 4 squared. And that's our derivative of y with respect to x using our quotient rule. Example number 6. Use the quotient rule to find the derivative of the function where p of t is the square root of t divided by 4t minus 3. Now the first thing I'm going to do before I do anything else is I'm going to write this t to the 1/2 power. So we have to do that in order to find the derivative. So my numerator is t to the 1/2. My numerator's derivative is the power times the base to the power minus 1. That ends up being 1/2 t to the negative 1/2. And we'll deal with that negative 1/2 a little bit later. We're going to leave it like that for now. Denominator's a little easier. 4t minus 3, that's a 2-term, so put parentheses around it. Our denominator prime is just 4. So our rule for our derivative this time is our denominator times our numerator prime minus our numerator times our denominator prime over our denominator to the 2nd power. So p prime of t is our denominator, 4t minus 3, the derivative of our numerator, 1/2 t to the negative 1/2, minus our numerator, t to the 1/2, times the derivative of the denominator, which is 4. All of that is over 4t minus 3 squared. That's your half credit answer. Now we got to clean this up just like we did before and see what kind of reducing we can do. Okay, so I'm going to multiply this 1/2 t to the negative 1/2 here, and then I'm going to multiply that, and that's just a monomial times a monomial, so that one's not too bad. Okay, now remember the rule for exponents. If you have t to the m times t to the n. You're going to add your exponents, even if they're fractions. So I've got 4 times a half, that's a 2. Let me write down what I'm doing here. I'm doing the 4t times the 1/2 t to the negative 1/2, right? So the first thing is this 2 goes in this 4 and leaves a 2. And now I have to add the 1 plus the negative 1/2. Well, that's 1/2. So I end up with 2t to the 1/2 minus 3 over 2 t to the negative 1/2. Okay. And then I've got a minus 4 t to the 1/2. And all of that is over 4t minus 3 squared. Now, I can't leave this like this because I've got some terms that can be combined. And I also have a denominator inside of a fraction. So look, I've got this fraction inside of a fraction. So I can't leave it like that. So the rule says, if you want to multiply a fraction, you have to do the top and the bottom by the same thing. So to get rid of this little denominator, I'm going to multiply everybody by 2. So 2 there, 2 times that one, 2 times that one. But don't forget, it's 2 times this denominator also. So I have to do the top and the bottom, all terms. Those are the things that are added and subtracted, 3 on the top and just the 1 on the bottom. And then we can simplify. 4t to the 1/2 minus 3t to the minus 1/2, right? Because this 2 and this 2 cancel out. That was the whole point of multiplying by 2. Minus 8t to the 1/2. All of that is over 2. 4t minus 3 to the 2. Okay? And we're almost to a satisfactory full credit answer, but I do have some like terms. 4t to the 1/2 minus 8t to the 1/2 is a negative 4t to the 1/2 minus 3t to the negative 1/2. And all of that is over 2 times 4t minus 3 squared. Now, that's almost a full credit answer, but the little issue here is that you have this negative exponent in this numerator. And we don't want to leave a negative exponent. So remember what this is. This is negative 4 t to the 1/2. That's going to be a square root in a few minutes. Minus 3 over t to the 1/2. All of that is over 2 4t minus 3 squared. So I'm going to do a similar thing that I did a few minutes ago, and I'm going to multiply all terms by this denominator, t to the 1/2. So I want to get rid of that denominator. I'll do this one too. All right? And remember, when you multiply, you add exponents. So this is going to be negative 4t, because a half plus a half is 1. And then let's see, we have a minus 3. See, that's going to cancel out, and that minus 3 is all that's left. I'm not sure what that extra mark is there, but that's 4t minus 3 over 2t to the 1/2. I'm just going to put that in the front. And 4t minus 3 quantity squared. Now, there's one other thing we got going on here that's not considered completely reduced. And that is we have a radical 2 square root of t 4t minus 3, we have a radical in our denominator. So in order to clear a radical, and look, this has more than one term, so I'm going to put parentheses around it. We multiply the top and bottom by that radical, as long as it's a monomial, and it's going to cause this square root of t to cancel out, because watch why. Negative 4t square root of t minus 3 square root of t over, if I multiply this monomial times this monomial, okay, that's 2 square root of t times square root of t. Well, square root of t squared is just t, or you can look at it this way. T to the 1/2 times t to the 1/2. Well, you have to add the exponents, and a half plus a half is 1. So again, I get a t, and there's that 2 there. So it's going to end up being 2t times 4t minus 3 squared. Now, what they did in my math lab on an example like this is they pulled out a negative square root of t, and that meant left inside would be a positive 4t and a plus 3, and then the denominator stayed as 2t, 4t minus 3 squared. Now, either one of these is a full credit answer, and if you can get to something like this, that's about a 90% answer. It's very, very close to the correct answer, but it's that negative exponent that's a problem. So remember, this is the standard protocol for mathematics simplification is no negative exponents and no radicals in denominators. So it's there, like I said, there's a lot of algebra in this. You can enter something like this, and my math lab will probably take it. So if all of this other stuff is really frustrating to you, don't worry too much about it. It's not the calculus. It's just a few points off the problem. Anyway, our final answer in the most simplified form is either one of these. So negative 4t square root of t minus 3 square root of t over 2t 4t minus 3 squared, or factored out negative square root of t and 4t plus 3 over that same denominator. Number 7, use the quotient rule to find the derivative of the following. Y equals 4x squared plus 7 times 3x plus 8, all of that divided by 5x minus 8. So look, we have a product here, and we have a quotient because of this fraction bar. So we're going to have to use both the product and the quotient rule. So this numerator has two parts, 4x squared plus 7 times 3x plus 8. So that's a first and a second, because we're going to have to use the product rule when we do n prime. And then the denominator is 5x minus 8. So our d prime is simple. It's just a 5. So let's do our n prime. If we put f times s prime plus s times f prime. So first derivative second plus second derivative of the first. It's going to be first 4x squared plus 7. Derivative of the second, 3, plus the second, 3x plus 8, derivative of the first, 8x. Let's go ahead and simplify this. 12x squared plus 21 plus 24x squared plus 64x ends up 36x squared plus 64x plus 21. Now that's the numerator prime, the whole numerator, okay, considering both factors. So here's your n prime, here's your d prime, here's your n, and here's your d, and we're going to use the quotient rule, which says dy dx is denominator times numerator prime minus numerator times denominator prime over denominator squared, which is 5x minus 8, and that's times the derivative of the numerator, that's that trinomial, 36x squared plus 64x plus 21 minus the original numerator, those two binomials, 4x squared plus 7 times 3x plus 8 times the derivative of the denominator, which was just a 5. And all of that is over the denominator squared. So this is your half credit. And simplifying this is where it gets to be the toughest. So now I have to distribute both of these in this binomial, 5x minus 8, to all three terms of the trinomial, and then come back and multiply the negative 8 times all three terms in the trinomial. And I've got to watch my signs carefully. So 5x times 36x squared is going to be 180 is going to be 180 x cubed. And then 5x times 64x is plus 320 x squared. And then 5x times 21 is plus 105x. Now I'm going to take the minus 8 through. Minus 8 times 36x squared is minus 288 x squared. And then minus 8 times 64x is minus 512x. And then minus 8 times 21 is minus 168. Now, I have choices for this part. And what I'm going to do is choose to do the minus and the 5 last. It'll keep me from making a sign mistake. This has to be fulled out. So 4x squared times 3x is 12x cubed. And then 4x squared times 8 is plus 32x squared, and then 7 times 3x plus 21x, and 7 times 8 is plus 56. Now be careful, we're not doing the 5 yet, it's here in the front. Now don't forget that all of this is still over 5x minus 8 squared. So I can go ahead and combine a few of these things. Let's see, I've got 180 x cubed, but I can combine the 320 and the minus 288 x squared for plus 32x squared. I can combine the 105 and the minus 512 for a minus 407x. And let's see, that gives me the cube, the squares, the x's, and then there's a minus 168. And then this 5 is minus 60x cubed minus 5 times 32 is 160x squared minus 5 times 21 minus 105x, and then minus 5 times 56 is minus 280. All of that is over our denominator, 5x minus 8 quantity squared. So our last step is combine our like terms. So x cubes, I have 180 and minus 60. So that's 120 x cubed. For my squares, I have a 32 positive and a minus 160. So 32 minus 160 is minus 128 x squared. Then for my x's, I have a minus 407 and a minus 105. So negative 407 minus 105 is a minus 512x. And then lastly, I have a minus 168 and a minus 280. So minus 168 minus 280 is minus 448. And all of that is over, finally, my final answer, 5x minus 8, quantity squared. So while there are not that many steps between half credit and full credit, there are a lot of places where if you're not careful, you'll make a sign mistake or an exponent mistake. So you just have to take it slowly, and if you need to, do some of the work on the side, and then bring it back and put it in. You don't have to do it all exactly in line like this. But if you'll follow this format, I can give you partial credit somewhere between the half credit and the full credit, as long as I can follow what you're doing.